Uh, uh, yeah. Hello, everyone. Welcome to Group 2 Project Report. And I'm Oliver. And first, I will introduce our team member. And hi, Jesse. And hi, Bree. And Hannah. And Jana. So today, our project is news popularity in social media platform. And you guys, for us, and Facebook, LinkedIn, and Google Plus are not just a place to share the personal interest, but also great platform to post news. We can see tons of news appear on this platform every day, and the popularity of them varying from each other. We want to do some analysis and try to find out what kind of the words appear in news will attract people most. About our data, we find a large data set of news items and their respective social feedback on multiple platforms, and Facebook, Google+, and LinkedIn. And the data set of news is collected between November 2050 and July 2060 with 93,239 rows and 11 columns. Next. And then we have several steps to analyze this data set. And first, the processed data. And this is our original data set. On the left side of the page, we have a data dictionary to introduce every variable meaning. And based on the original data set, we recode some columns and extract some information that might be more meaningful for doing text mining. And in this original data set have 4 topics: and economy, Microsoft, Obama, and Palestine. Next. We subset the data set based on its topic. And our goal is to find people are most interested in what news about Obama and what kind of news about the economy. Then we got the processed data set in there and compare the original data set. We drop some columns and we add 3 new columns, published over and the times of the news item publication. And next is the total popularity. And we sum of the final value of the news item popularity on 3 social media platforms. And finally, binary pop is our target variable.
The second step of data proposing is to ignore some types of word. Here is the 7 part that we need to ignore. And next, the third step is to find the synonyms. Here are some synonyms that we found, such as China is same with Chinese, or president is same with president in different word types. And we will provide a complete table of synonyms in our document. And then next, we need to follow each step to do the model. First is to input the data. We need to cover the text from CSV to SAS and drop input data source to diagram. And the most important thing is that we need to change the rows of variables. We need to change the row and level of binary pop to target and binary, and we also drop the total popularity in our data set. And next, in the text In the text parsing, we ignore some text of word and the synonym and add the synonym data side using text filter in order to specify the different terms with same root. And from the results, we can find that President Obama, Washington, and White House are the top frequent terms in our topic. And that's all.
We use text filter after text parsing to convert text to document. During the text filter process, we exclude terms which occurred in fewer than 4 documents because they are so rare and there's not much information we can get from them. Then we change the frequency weighting to log and weighting to entropy. After that, we open up the filter viewer to find synonyms and remove words that we think are useless in text mining. Now let's look at the result of text filter. We put 2 graphs on the left. The red bar shows the dropping attribute and the blue bar shows the remaining attribute. We can see it successfully dropped 92,476 attributes in group alpha from our dataset, including 25,000 verbs, 35,000 nouns, and 15,000 adverbs. Next. A process after text filter is text cluster. During the text cluster process, we set the SVD resolution to high and maximum SVD dimension to 6. When we look at the pie chart here, the cluster 2 has the most frequency, while the cluster 5 has the least. When we look at the table of the cluster, we guess that cluster 2 are news related to gun control and cluster 5 are news related to Supreme Court. After text cluster, we will guess some new creative variables such as text cluster probability. We won't use all of them in every model we create later, otherwise it will result in redundant information. Thus, we add another process called metadata to modify the rows of variable we have right now. The graph on the right shows the original rows of variable and the new row we have assigned to them. We didn't make many changes here, but we did change the row of text cluster to cluster from segment to input.
To gain some insights into the correlation between our predictors and target, we added Stat Explore node before entering into the modeling part. From the chi-square plot, we can detect that the variable publish hour has significant effect on our categorical target in train data. Then are the SVD dimensions. The the least significant variables are the two numeric variables. Then follows the data partition node. We set the ratio of training data and validation data as 75% to 25%. Next slide. Now you can see 4 of our models we choose to use were all selected from our data mining lecture. Since we've already conducted text mining and 6 clusters are available now for each topic, we are going to use these clusters as an input in the regression model part, decision tree, and the neural network. We built 3 regression models. One only includes the SVD dimensions, one only includes the numeric variables, and the other one includes the both. Besides, the reason why we chose neural network is because that it is a powerful black box machine learning tool from which we are more likely to get a higher accuracy. Next slide, please. Here is our diagram for the prediction of popularity of Obama-related comments. After our data partition node, we connect the 5 models mentioned in the previous slide with the model comparison node. Next slide. For the 3 logistic regression models, we use the stepwise selection method based on cross-validation misclassification. For the decision tree, we did modification on the leaf size, minimum number inside each branch, number of splittings, and surrogates. We tried different combinations of these settings. For neural network and decision tree, we set default for all the variables to be used, which means the numeric variables and SVD dimensions will all be included in the training process for those 2 models.
Then we move on to model comparison. The result indicate that the neural network and decision tree are better than all others, showing on the ROC and cumulative curves. In ROC, these 2 are closer to left side, meaning that the less mistake we will have. And the left curve of those 2 models is higher in the chart, meaning that we capture top 10% of variables. We can reach out to around 50% of the whole variables. Also, the accuracy in these models are greater than 50%, showing from the misclassification rate. Next, when we take a look at the parameter analysis of the full regression model, the published hour and the cluster 2 have a stronger positive impact on popularity, and cluster 6 has a strong negative impact. So we can look back to the text cluster. The cluster 2 includes gun shooting and attack, which means the Obama news related to those keywords get more attention at that time. On the other side, while the cluster 6 indicates that public is less interested in the topic about Donald Trump and Hillary Clinton during Obama administration period. We also explore the news economy grouping from our raw data set, and we duplicate almost every single step from the previous one. The following is the whole process of news economy exploration. As we can see in the result, publish hour is still an important variable, and cluster 3 shows that for economy news, people pay more attention on the job market, interest rate, and the Federal Reserve policy. All right, that's all for our presentation. We are group 2. Thanks for watching.